All right, our next example says, suppose grade point averages for undergraduate students at one university have a bell-shaped distribution. Okay, so right away, when I know bell shape, I draw my bell curve. Now I'm going to be applying the empirical rule. We have a mean of 2.54, so mu is 2.54, and standard deviation is 0.42. So sigma equals 0.42. Okay, so I'm going to draw my mean in the middle, 2.54, and we're going to be adding and subtracting the standard deviation to find what percentage of students have a grade point average between 1.28 and 3.8. So I need to find out how many standard deviations I need to go to the right and to the left to get to those values. So again, not easy numbers to add. So I'm going to go to the calculator, type in 2.54 and just hit enter, and then say add 0.42. So when I add 0.42 the first time, I am at 2.96. And if I just tell it enter to do it again, I am at 3.38. And then I hit enter to tell it to do it again, I'm at 3.8. So we have gone 3 standard deviations to the right. Now I'm going to start over. I'm going to type 2.54 and hit enter. And now I'm going to subtract 0.42. And the first time I am at 2.12. And then when I subtract it again, I'm at 1.7. And then we subtracted a third time. Well, I did it twice, but the third time we're at 1.28. And we want to know the percentage that are between these. Okay. So according to the rule, when we go 1, 2, 3 on either side, between these two numbers is 99.7. Okay. So that was the original empirical rule, okay, that we drew out. If you add it 3 times, so between 3, 99.7. So there's no work that you have to do other than adding and counting how many standard deviations. You have to go right and left. And if it's an even number on both sides, 1 and 1, 2 and 2, 3 and 3, then we can apply just the general empirical rule, the 68, 95, 99.7. If there's an uneven amount on either side, then we use the other breakdown where we have to add up the pieces to find the total. So in this case, just 99.7.